Hello again, Year 9, and welcome to our second lesson on the chemical world. In this part, we're going to have a look at what actually makes up an atom, aka what is atomic structure. Now, atoms themselves, we've said they're the tiniest building blocks of matter, but that's actually a bit of a lie, because in reality, atoms, while they make up everything, are actually made of smaller particles themselves. Now, these particles are called subatomic particles, and there's three main types. I've listed the three main types up here, and they are the proton, which is positively charged, we have the neutron, which is neutrally charged, and we have the electron, which is negatively charged. So they're our three main particles that go together to make an atom. Now what I've done is I've taken some of these particles and I've used them to construct these models, these images of what scientists think atoms look like. Now, we can't look at an atom under a microscope, they're far too tiny. So over history, what scientists have done is they've done a whole bunch of experiments, very, very smart experiments, where they're able to deduce what an atom would look like, even if we can't literally look at it. And they came up with a model very similar to what we see here. So what is going on here with this picture of all these circles? Well, I've kept the color code, and as you can see, we have protons, neutrons, and electrons in the atom. But it needs to be pointed out that the protons and the neutrons are squished together in this tiny centerpiece called the nucleus. Now, the nucleus is a word you've seen before. In biology, it means the center of the cell where the DNA is contained. So what you can take from this is the nucleus is the center of something. Now, this nucleus is the center of the atom. It's also very, very heavy because protons and neutrons have a mass roughly equal, which we equate to being 1. So that all adds up in the middle. The electrons are so tiny that we round their mass off to be 0. So this part of the atom is very, very heavy compared to this outer part of the atom. Now I'm going to talk about the outer part of the atom. Whilst we have protons and neutrons here in the nucleus, and they're stuck there, the electrons are not stuck. So these electrons are actually traveling around a path like an orbit. So this big blue circle you see isn't actually a part of the atom. It is actually the path that these electrons take as they orbit around the nucleus. And we can see that there's 2 here for this element that I've drawn, helium. So this is a helium atom. Now, what else makes this a helium atom? Well, it has atomic number 2 helium. It's number 2 on the periodic table. And what does that mean? Well, it means it has 2 protons and it means it has 2 electrons. And that is why I've drawn 2 of each in my picture, 2 protons in the nucleus and 2 electrons orbiting around the outside. Now, what you might have noticed is I've put 2 neutrons there as well. Now, I've put 2 neutrons there because I know that most helium atoms have 2 neutrons. Some have more, some have less. Okay, but we'll get in the exact rules for how many neutrons we should draw in an atom in another part. But now, I just want you to remember that the atomic number, that number at the top of each square for each element in the periodic table, tells us exactly how many protons and how many electrons each atom of that element should have. So what I've drawn over here is another element. Now, this element is only 1 atomic number larger than helium, but it's very, very different. It is the metal lithium. We know helium is a very light gas. We put it in balloons. Lithium is a very soft reactive metal, kind of like sodium, which I've already spoken about. Now, this is an atom of lithium, and it's a little bit different. It's got the main bits, but the bits are different. So let's have a closer look. What we have is 1, 2, 3 protons, which is what we should expect. The atomic number on the periodic table of lithium is 3. So therefore we have 3 protons. And around it we have, in these blue orbitals, 3 electrons matching perfectly with the atomic number. Now, as I said with the helium, I just happen to know that lithium most of the time has 4 neutrons, so that's why I've drawn 4 neutrons. As I said, we'll get into it in another lesson, figuring out exactly how many neutrons we should draw if we have to draw an atom. So watch this space. For now, just remember that it has an atomic number of 3, therefore it has 3 protons in the nucleus and 3 electrons orbiting. Now, there's one really important difference that I need to point out between these two atoms, these two elements. And that is, there's a whole extra blue circle over here. Why is that happening? Why have I drawn that? Well, another thing about these electrons is they orbit in shells, layers. Okay? Now, the first layer, no matter how many layers an atom's going to have, the first layer always contains two. Always contains two. So helium, with only 2 electrons, has its 2 electrons in only one shell. Now, this first shell can only carry 2 electrons, but that's all right for helium because it only has 2 electrons. It's a nice fit. But when we go over to lithium, we see something different has to happen, and that is lithium has 3 electrons. Now remember, I said the first electron layer can only fit 2. Can only fit 2. So what do? We have to put the 3rd electron into a 2nd layer. Now what does this do? It makes the atom quite a bit larger than helium. So if I was to put a lithium atom and a helium atom next to each other and actually get a look at it, I've noticed that the lithium atom is quite a bit larger than the helium atom simply because it's got that extra electron orbital. Okay?